All right, so we're going to do the second part of our notes for our slope-intercept form, which would be, what is that? Graphing linear equations in slope-intercept form, which is 3.5. So this is day 2. Let's go ahead and fill in this box here. You'll probably remember a lot of this from last year, but slope-intercept form. A linear equation written in the form y equals mx plus b is in slope-intercept form. The slope of the line is the m, and the y-intercept is the b. So we're just going to make this a little bit easier to see. Y equals mx plus b. I'm going to write down that the m is the slope, and the b is the y-intercept. And if you look over here, the y-intercept, again, is where it crosses the graph on the y-axis, and it's the point 0, comma, b. So if you can just identify your slope, identify the y-intercept, boom, you're going to be really good. So example 3, this will be pretty quick and easy. Identify the slope and the y-intercept. Remember, the slope is the m, y-intercept is the b. So whatever's multiplying the x is your slope. So I'm going to here say my slope is the 3 and my b is the -4. I know that because y equals mx plus b. And notice my 3 is where my m is, and my -4 is where the b is supposed to be. In part b here, if I write y equals mx plus b, you'll notice that y equals 6.5 is missing an x, which means it really had a 0 in front of the x, because magically it disappeared when you multiply by 0. So in this question, I would say that my slope is 0 and that my intercept is the 6.5. That's my y-intercept. Now I can write the b. I don't know if we do it online, if it'll say y-intercept instead of b. It might say y-intercept equals -4. That might be as well. So maybe it's a good habit right now, instead of just writing b, also you could think of it as the y-intercept. I'm okay with either one on a quiz, y-intercept or b. Now with c, we want things in y equals mx plus b form. So we need to, quote unquote, solve for y. We did this in the first chapter. You may or may not remember, but we did. So first thing, I'm going to add 5x to both sides. Notice these are unlike terms, and to help me with my slope-intercept form, I'm going to put my positive 5x first and my -2 after it. So it says -2, and I have to keep this a negative y equals 5x minus 2. And because of this negative, I'm dividing everything by a -1. So I get y equals -5x. Negative divided by negative is a positive. So there's my equation. Now I can identify that my slope is -5 and my y-intercept is 2. All right, you can do the next 3 on your own. Pause the video and then I'll tell you the answers. All right, now that you did those on your own, I'm going to write down that the slope here is -6 and the y-intercept is 1. Here the slope is 0, the y-intercept is 8, and this one you had to rewrite it, and then when you did, you would have gotten y equals -1/4 x minus 5/2, or maybe you wrote that that was -2.5, either one. So I can write here that my slope is -1/4. Notice how I like to keep it a fraction instead of a decimal. It's that rise over run, so when we graph, it's helpful. And then my y-intercept here, or your b value, is -5/2, or you put -2.5. All right, example 4. We're going to graph this and identify the x-intercept. So first thing, let's rewrite this. Let's get y by itself. So subtract 2x from both sides. I get y equals -2x plus 2. So when you graph this, first identify the slope, which is -2, and identify the y-intercept, which is +2. So what we do is you are going to plot your y-intercept first. So I'm going to go up to +2. Booyah, right there. Then use slope to plot many points. All right, so my slope is -2, but let's make it a fraction. So we have a rise and we have a run. Now remember, negative means it's going downward. So from here, I'm going to go down 2 to the right 1, down 2, right 1, down 2, right 1, down 2, right 1, down 2, right 1. I'm going to keep going. And then I can go backwards. So instead of down 2 and right 1, I can go up 2, left 1, up 2, left 1, up 2, left 1, up 2, left 1. I want to fill up the whole graph, and then I can take my handy dandy ruler, which I'm going to have to adjust this because I'm using the computer here, connect these and put arrows on the end. There we go. Oh, it's not quite there yet. Almost. Boom. There we go. And then the x-intercept is right here. So I can write down that the x-intercept is the point 1. Or you can write down the point 1, 0. All right, over here, example 5. A linear function models a relationship with the dependent variable. Dependent means your y. So right here, this is your y variable. Increases by 3 for every 1 unit. The independent variable, which is your x, increases. So this means that my change in y, which is the dependent variable, increases by 3. And our slope formula says change in y is divided by the change in x, while the change in the independent variable is 1. So here's my slope. I have a slope of 3 over 1. And then notice my input-output here. When I input 0, g of 0 equals 3 means I have the ordered pair 0, 3, which is my y-intercept. So I'm going to graph my y-intercept, which is 3, 1, 2, 3. And I'm going to use my slope, which is up 3, 1, 2, 3 over 1. Up 3, 1, 2, 3 over 1. I'm going to go in reverse. Down 3, 1, 2, 3 over 1. 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 I'm sure you're all getting sick of me saying that by now. Now I can take my handy dandy ruler and connect the dots here. Come on. Let's see. There we go. It should work like this the very first time I use it. All right. And then it says identify the slope. So we have slope here. Identify the y-intercept. The y-intercept is 3. And then the x-intercept of the graph is right here. So the x-intercept is -1, also known as -1, 0. Oh, there we go. So there's some on your owns for graphing. You can do that. And then there is an on your own for another one like this. I'm not going to write those down just for the sake of time. So you can do these. But let's get to example 6. A submersible that is exploring the ocean floor begins to ascend. That means you're going to go from the bottom up to the surface. So surface is like sea level, and below the surface is negative altitude, negative feet. Okay, so the elevation, represented in h, of the submersible is modeled by the function h of t equals 650t minus 13,000, where t is the time in minutes. Graph the function, identify its domain and range. All right, first of all, if I'm going to graph this, I know that I have a y-intercept of -13,000. So that's where this is a little hard to do. So if I was going to scale this, I would say maybe like -2,000, -4,000, -6,000, -8,000, -10,000, what's that going to be? 12,000, -14,000. I know at 0 minutes, I'm at -13,000, which is right here, halfway between. So that I can't go any further. I'm already in the bottom. So I know that my domain is going to be an inequality here. And and when I get to the surface, that's an altitude of 0. I'm eventually going to hit 0. So I know I'm somewhere between negative 13,000 feet, less than or equal to x, less than or equal to, actually technically it'd be h. I guess we could put an h here. H all the way up to 0. Sorry, that's not the domain, that's the range. That's the range. I'm so sorry. That's the range because that's my y values. My x values are going to be the time, so the domain is going to be based on time. I know it's going to be 0 because you can't have negative time, less than or equal to t, less than or equal to, we have to figure out when it hits up here. So to figure that out, I want to know when is the height 0. So I'm going to quickly go over here and say 0 equals 650 t minus 13,000. So I'm going to get 13,000 equals, man, I cannot write. 13,000 equals 650 t. When I solve, I get 20 equals t. So I know it's going to take up to 20 minutes. So I'm going to count by 2s, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. At 20 minutes, I am at sea level. So this doesn't have arrows. It's just going to go right here. Come on. Go right here. Boom. So there's my graph. So I identified the domain and range. The slope is going to be 650, and then the intercepts. My x-intercept is 20. My y-intercept is negative 13,000. All right, there is one on your own that you can do after this if you want. I'm not going to model that and do it, but it's a very similar question. All right, just some different numbers. So hopefully that was helpful. Best of luck on this lesson, and just reach out if you need any help.